Hello guys, I'm Carlo Ticagente from Math 3B and we will answer chapter 7.1 confidence interval and sample size. Question number 5. What is the three properties of good estimator? The three properties of a good estimator is number 1. The estimator should be unbiased estimator. It means that the mean of the point estimate obtained from all samples of a given size is equal to the parameter being estimated. And number 2, the estimator should be consistent estimator. For example, as the sample size increase, the value of estimator should approach the value of the parameter being estimated. And lastly, the estimator should be relatively efficient. The variance of the estimator should be the smallest of the comparable estimators.
Good day everyone, I am Arvin J. Emilio from BSED Math 3B. For today I will discuss the item number 13 under 7.1, confidence intervals for the mean when population standard deviation is known and sample size. So, let's get started. So for item number 13, we have the workers' distractions. A recent study showed that the modern working person experiences an average of 2.1 hours per day of distractions. Phone calls, emails, impromptu visits, etc. A random sample of 50 workers for a large corporation found that these workers were distracted an average of 1.8 hours per day, and the population standard deviation was 20 minutes. Estimate the true mean population distraction time with 90% confidence and compare answer to the results of the study. So for our step 1, we will just write all the given from the statement given. So we have 50 workers. We have 1.8 hours. We have 20 minutes. And we have 90% confidence. So for step 2, we will just convert some of the given into a value that we needed for substitution in the given formula. So first, we will convert 20 minutes into hours. So we will have 0.0333 hours for our given. Next, we will convert the 90% confidence. So we will just subtract 1 from 0.90. So that would be equal to 0.10. And then after that, we will divide 0.10 into 2. So upon solving, we will get 0.05. And then we will subtract 1.000 to 0.05 for us to get 0.9500. From table E, we will get the z value of 1.65. Now we're ready to go for step 3. So we will just substitute all the given to this formula. Population mean is greater than the sample mean minus z sub alpha multiplied by population standard deviation over the square root of sample size, but less than sample mean plus z sub alpha multiplied by population standard deviation over the square root of sample size. So we have 1.65 for our z value, 0.333 as our population standard deviation, 1.8 hours as our sample mean, and 50 as our sample size. So substituting all of those to this formula, we will have population mean is greater than 1.8 minus 1.65 multiplied by 0.333 over square root of 50, but less than 1.8 plus 1.65 multiplied by 0.333 over square root of 50. So solving that, we will have population mean is greater than 1.72 but less than 1.88. Hence, we can say with 90% confidence that the true mean population distraction time is between 1.72 and 1.88. So it is lower than the results of the study. I think that will end my presentation for this day. Thank you so much for listening, and God bless us all.
For item number 21, time on homework. A university's dean of students wishes to estimate the average number of hours that students spend doing homework per week. The standard deviation from the previous study is 6.2 hours. How large a sample must be selected if he wants to be 99% confident of finding whether the true mean differs from the sample mean by 1.5 hours. We use the formula n is equal to the confidence interval multiplied the standard deviation over e squared, where n is equal to the next whole number of the sample size, and z sub a over 2 is equal to the confidence level, and sigma is equal to the standard deviation, and e is equal to the margin of error. Then we solve for the value of the confidence level, where z sub a over 2 is equal to 1 minus 0.99 is equal to 0.01 over 2 is equal to 0.005. And if we add 0.99 plus 0.005 is equal to 0.9950, and we use e-table for that, we come up the value of confidence interval is equal to 2.575. We know that the formula of getting the sample size is equal to the n is equal to the confidence level multiplied the standard deviation over e squared. And the standard deviation is equal to 6.2. The confidence level is equal to 2.575. And the margin of error e is equal to 1.5. And b equal to n is equal to 2.575 times 6.2 squared over 1.5 is equal to 1.717 times 6.2 squared. And b equal to 10.645 squared. And n is equal to the 113.31, and n is equal to the next whole number of the sample size, which is n is equal to 114. And I'm Carlo T. Cagente. Thank you for watching.